A very good morning, children. In the previous lecture, we had seen how the Bohr's model of atom had failed because of various reasons. Bohr's model of atom could be applied only to single electronic species like hydrogen or helium plus or lithium 2 plus. So, it was not applicable to the species which were having more than one electrons. He could not explain it. The other reason was that he could not explain the splitting of lines of the hydrogen spectrum when it was placed in the electric field or magnetic field. So, that was another drawback or the disadvantage or the limitation of Bohr's model. Thirdly, he couldn't explain the chemical bonds which were taking place between the atoms to form a molecule or a compound. So, various reasons led to the failure of the Bohr's model. So, it was during that time that the scientist felt a need to have a new set of rules which should be put forth for the microscopic world. That is wherever we are dealing with very small particles like electron or an atom. Okay. So, for that they required a new set of rules. So, that was the time when the birth of quantum mechanics took place. Okay. So, quantum mechanics had to have a new set of rules for for understanding the microscopic world. Okay. So, quantum mechanics, which was around that is the postulates and all the researches were done during the year from 1926 1927. The concepts relating the quantum mechanics had started with, and very two important scientists, that is this quantum mechanics what was proposed by two people, that is Erwin Schrödinger and Werner Heisenberg. Both of them, they separately proposed all these concepts about the quantum mechanics, but it was found that almost they were talking about the same thing. Okay. So, these two scientists, Erwin Schrödinger and Werner Heisenberg, were considered to be the people behind the concept of quantum mechanics. Okay. Now, they said that there has to have some certain postulates which had to be developed to understand this quantum mechanics. Okay. So, postulates of quantum mechanics, there are many postulates, but for our discussion or our level of studies, we will take only two of them, and that is for every quantum, first one, for every quantum mechanical system, there exists something called as wave function. Now, what is this mechanical system meaning? This mechanical system, it can be anything like an electron or many electrons. We are studying about many electrons, or we are trying to understand only one electron, or we are trying to understand an atom. So, it can be any mechanical system. Okay. So, what does it say? For every quantum mechanical system, there exists something which we call as wave function. Wave function मतलब ये है उसका representation. This is called as psi. This is in the capital case and this is in the small case. Okay, what is it called? This wave function is called as psi, psi. Okay, and the symbol is this thing. This is your capital case में और ये small case में. So what is it saying? कि कोई भी सिस्टम जिसको हम स्टडी कर रहे हैं, उनके पास एक चीज़ है जिसे वेव फंक्शन कहते हैं, और वो वेव फंक्शन के पास सारा इन्फॉर्मेशन होता है जिसके बारे में हम स्टडी कर रहे हैं. जैसे अगर हम एक इलेक्ट्रॉन के बारे में स्टडी कर रहे हैं, तो ये जो साई है या वेव फंक्शन है, उस वेव फंक्शन के पास वो इलेक्ट्रॉन के बारे में सारा इन्फॉर्मेशन है, लाइक पोजीशन ऑफ इलेक्ट्रॉन, मोमेंटम ऑफ इलेक्ट्रॉन, द एनर्जी ऑफ द इलेक्ट्रॉन. ये सारी इन्फॉर्मेशंस जो है वो किस में एग्जिस्ट करता है? ये साई में एग्जिस्ट करता है. Have you understood the first postulate? What does it say? That for any mechanical system, अभी हमने एक इलेक्ट्रॉन को स्टडी किया है, सपोज हमने 100 इलेक्ट्रॉन्स को साथ में लेके स्टडी कर रहे हैं, तो वो साई जो है जिसे हम वेव फंक्शन कहते हैं, this particular wave function which is represented by psi, it has all the information regarding all the 100 electrons, regarding its position, regarding its energy, regarding its momentum. सारा information किधर present है? ये psi में present है. Again once more, what is the first postulate of quantum mechanics telling you? That for any mechanical system, अभी हम तो chemistry के बारे में पढ़ रहे हैं, तो हमारा main aim क्या है, study का content क्या है कि हमें electron के बारे में जानना है ना? तो for a quantum mechanical system like an electron, ठीक है, there exists something which we call as wave function represented by this letter psi, and this psi has every information which we need to know regarding that electron. So that was the first postulate put forth in the quantum mechanics. ठीक है, तो ये जो मैकेनिकल सिस्टम है ये कुछ भी हो सकता है. इट कैन बी एन इलेक्ट्रॉन और इट कैन बी मैनी इलेक्ट्रॉन्स, इट कैन बी 1000 इलेक्ट्रॉन्स ऑल्सो, और इट मे बी एन एटम, और इट मे बी अ क्लस्टर, बट एनी मैकेनिकल सिस्टम, ओके, it has a wave function, and this wave function has all the information regarding that system. That was the first postulate. So if a system, if you are talking of an electron, then the wave function psi will contain all the information about this electron. I hope the first postulate is clear. Or another thing is that ये जो wave function psi है, it does not have any physical meaning. Physical significance कुछ भी नहीं है, because it is not required. What has a physical significance is the psi mod square. Psi mod square जो है, it has got a physical meaning, and it means the probability of finding an electron at a given point in space. So what does psi mod square represent? It shows the probability density we call. That is the probability of finding the electron at a particular point in the space. That is called as probability function, or probability density also we say, and that is represented by psi mod square. ठीक है, so psi mod square, since it is a probability, it cannot have a negative value, it will always take a positive value. ये सारी चीज़ें तुम्हें पता होना चाहिए. Psi mod square, it is the probability density, or it is the probability of finding an electron at a given point in a space. ठीक है, और psi mod square का वैल्यू जो होता है वो हमेशा पॉजिटिव ही रहता है, नेगेटिव नहीं होता. ओके, दैट वाज द फर्स्ट पोस्टुलेट. सेकेंड पोस्टुलेट इज दैट फॉर एवरी ऑब्जर्वेबल, ऑब्जर्वेबल मतलब जब हम सपोज हम इलेक्ट्रॉन के बारे में बोल रहे, स्टडी कर रहे हैं, तो उसका ऑब्जर्वेबल प्रॉपर्टीज़ या ऑब्जर्वेबल्स क्या है जो हमें चाहिए, वो क्या हो सकता है? या तो पोजीशन ऑफ द इलेक्ट्रॉन हमें पता करना होता है, या एनर्जी ऑफ द इलेक्ट्रॉन पता करना होता है, मोमेंटम ऑफ द इलेक्ट्रॉन पता करना है. सो दीज आर ऑल व्हाट वी कॉल एज ऑब्जर्वेबल. ओके, फॉर एवरी ऑब्जर्वेबल वी वांट टू नो देयर एग्जिस्ट एन ऑपरेटर. फॉर अभी क्यों ये ऑपरेटर का प्रॉब्लम आता है, या ऑपरेटर क्यों चाहिए होता है, कि हम बोल रहे हैं कि वेव फंक्शन में सारा इन्फॉर्मेशन है, तो अब ये वेव फंक्शन में से सारा इन्फॉर्मेशन निकाले कैसे? ओके, सो वेव फंक्शन में से इन्फॉर्मेशन निकालने के लिए वी रिक्वायर एन ऑपरेटर. ओके, नाउ व्हाट इज एन ऑपरेटर? Operator, you can understand, it may be as simple as just a plus sign, that is addition or subtraction or square root or square or derivative or integration. So ये सारे जो होता है ना, ये ऑपरेटर्स होते हैं. अभी एक एग्जाम्पल ले लो. सपोज इफ यू वांट टू अप्लाई द ऑपरेटर स्क्वायर रूट ऑन अ फंक्शन विच इज कॉल्ड एज 9. ये एक फंक्शन हुआ. ओके, जैसे 9 है वो हमारा वेव फंक्शन है. सपोज वेव फंक्शन इज 9, सो वी अप्लाई एन ऑपरेटर स्क्वायर रूट ऑन इट. सो व्हाट विल बी द आंसर फॉर दैट? You get it as 3. So have you understood? An operator has to be applied on a function to get the answer. ठीक है, ये तो 9 एक फंक्शन है, 9 फंक्शन में हमने कौन सा ऑपरेटर अप्लाई किया, रूट का ऑपरेटर 9 पे अप्लाई करने पे हमें आंसर मिलता है 3. सो हैव यू अंडरस्टूड? सपोज आई अप्लाई एन ऑपरेटर ऑफ स्क्वायर ऑन फंक्शन, लेट मी टेक 9. तो हमने फंक्शन 9 में हमने ऑपरेटर जो अप्लाई किया वो है स्क्वायर का, तो हमें आंसर क्या मिलता है, 81. नाउ आई होप यू अंडरस्टैंड व्हाट इज द मीनिंग ऑफ एन ऑपरेटर. So what does the second postulate say? For every observable, we want to know, we want to see there exists an operator. So for every observable there is an operator. Okay, when we are studying an electron, suppose. So for every observable there has to have an operator to get that information. Okay, first you just copy down. I will discuss more on this. Operator का मतलब समझे ना? Actually it is a rule which applies to a function. Okay, so here square root is an operator which is applied to a function 9. Here square is the operator which is applied to a function 9. I hope you understand that. Okay, please note this down so that I can go further. So we were discussing that for every observable like position, energy or momentum, we want to know there exists an operator. Okay, so what did I say? What is an operator? Operator is anything like a addition sign or a subtraction sign or a square root sign or a square sign. Okay, so operator is a rule which applies to a function. Suppose our function is 9, if you apply the operator of square root, then we get the answer 3. So it is a rule which is applicable to a function. So we can define, or we can say what is an operator. Operator is a rule which applies to a function. Okay. So if you want to know, suppose the position of an electron, we want to know the position of an electron, then what is the operator we have? We have the position operator. We represent by x. Suppose x is the letter we use to find the position of an electron, है ना. हमने अनसर्टेनिटी प्रिंसिपल में भी डेल्टा x यूज़ किया था टू आइडेंटिफाई द पोजिशन ऑफ द इलेक्ट्रॉन. सो इफ़ यू हैव x as the function which is position of electron, then we have to apply an operator which we call as position operator. Operator हमेशा हम एक hat ऊपर रख देते हैं for that function. So this is what we call as the position operator. Okay, position operator. So we have to apply the position operator on the function of position to find out the position of the electron. Okay, so we have to have a position operator if you want to find the position of an electron. If you want to find the momentum of an electron find करना है तो हमें कौन सा operator use करना पड़ेगा? P with a hat, and this is called as momentum operator. Okay, this is momentum operator. ठीक है. अगर हमें एनर्जी फाइंड करना है एक इलेक्ट्रॉन का तो हम कौन सा ऑपरेटर यूज़ करेंगे? वी यूज़ H hat, and that H hat is known as Hamiltonian operator. Hamiltonian operator, MIL आएगा इधर, Hamiltonian operator. Okay, it is given the name on the after the name of a British scientist, Hamiltonian. Okay, so Hamiltonian operator is the energy operator. If you want to find the energy of an electron, then we have to apply Hamiltonian operator. ठीक है. तो जैसे ये तो हमने सिंपल वे में समझा, लेकिन जब हमारा एम तो फाइंड करना है व्हाट इज़ द इंफॉर्मेशन अबाउट एन इलेक्ट्रॉन, वेयर डज द इलेक्ट्रॉन एग्जिस्ट इन द एटम, दैट इज़ आवर मेन एम, इजंट इट? सो दैट इज़ टू फाइंड द स्ट्रक्चर ऑफ एन एटम. So we have to apply all these kind of operators to find the momentum, to find the position, to find the energy of a particular electron. ठीक है. तो जब श्रोडिंगर ने ये हैमिल्टोनियन ऑपरेटर अप्लाई किया ऑन अ वेव फंक्शन, देन ही गॉट द आंसर एज एनर्जी psi. Since he has used energy operator, what is the answer he will get? He will get the information about the energy of the electron. Okay. So, this is called as the Schrödinger equation. Schrödinger equation is H psi equal to E psi. H is the Hamiltonian operator, psi is the wave function which contains all the information regarding the energy of the electron, because we are using energy operator here. Okay. Hamiltonian operator is the energy operator. So, we get E psi which tells you about the energy of the electron. तो ये जो equation है, इस equation को solve हमें नहीं करना है. We are not able to solve it because it's beyond our limit, beyond our scope of this particular class. So, we are not going into the solving of the Schrödinger equation, neither we are trying to obtain. अब ये तुम सोच रहे होंगे कि ये सारी चीज़ें obtain कैसे करते हैं, इसको develop कैसे करते हैं, तो ये सब हम इस क्लास में तुम्हें पढ़ना नहीं है. It is beyond our scope of this textbook. So, we will not go into that detail. You just remember that ये तुम्हारा Schrödinger equation है. Schrödinger equation is used to solve a particular function like position or momentum or energy of a particular electron. हम कौन सा mechanical system को learn कर रहे हैं? We are trying to learn the trying to find the or trying to get the information about an electron. Okay. So, when we apply a energy operator to a wave function psi, we get equal to E psi, where you get the various information regarding the energy of the electron. Okay. So, when solutions when we solve this Schrödinger equation, we got various solutions. So, how are we solving, that is not required. What are the solution or what are the results that we can discuss here. So, क्या result हमें मिला जब हमने ये equation को solve किया, तो we get a series of wave function. बहुत सारे wave functions हमें मिले and we call them as orbital or atomic orbital. We call them as orbital or atomic orbital, and this atomic orbital gives us the address of the electron. Are you understanding? So, when this Schrödinger equation was solved, we got a series of wave function, और ये wave function को हम क्या बोलते हैं? Orbitals, या simply orbitals भी बोल सकते हैं या फिर atomic orbitals बोलते हैं. Okay, and that atomic orbitals is that which gives us the address of the electron. You mean the address? No, address का मतलब पता है ना कि where the electron is existing, or it tells you about the house of the electron. How is the house of the electron? It tells you about the address of the electron. The next thing which it tells you is we also get a series of energy which corresponds to each wave function. We get lot of wave function है ना. First result वही है कि we get a series of wave function. For example, we get psi in many terms. Okay, बहुत सारे psi हमें मिल रहे हैं. We get wave function and each of these wave function is corresponding to a particular energy. Each of these wave functions is having a particular energy. That was the second observation. Okay, and these energies जो है ना उनका एक particular way है, हाँ, that is it has only discrete values, ऐसे continuous नहीं है. 5 है किसी psi का energy तो दूसरे psi का energy it should be 10. In between का कोई value नहीं लेता है. So, these energies have discrete values. That was another thing observed. So, I hope you understand what is the solution we obtained by solving the Schrödinger equation. When we solved the Schrödinger equation, this is the Schrödinger equation. Okay, this Schrödinger equation, when you solve, we got a series of wave functions, series of psi we got, and each of these psi will be now called as what? Atomic orbitals or simply orbital, and that orbital is actually giving you the address of the electron. Okay, so I hope you understand that. So, Schrödinger equation कैसे solve किया था? Hamiltonian operator was applied on the wave function which gave you the result as E psi, which is regarding the information regarding the energy. Okay, तो इधर unknown quantities कौन सा है, size and unknown quantity and also energy, ये दोनों ही unknown quantities थे. ठीक है, और Hamiltonian operator that was only the known quantity. Okay, तो ये सारी चीज़ें you have to get it, and solving them we get series of wave function, and each wave function will be called as an orbital, and these wave functions corresponds to a particular energy, and these energies are having discrete values, it does not have a continuous value. So these were the things obtained when a Schrodinger equation was solved. ठीक है, now what does this atomic orbitals tell about? So this atomic orbitals या जो wave function हमें मिला, these atomic orbitals tells about the size of the house of the electron, it tells you the shape of the house of the electron, and it also tells you the orientation of the house of the electron in the space, वो किस तरह oriented है in the space. I hope you understand. So atomic orbitals, which is known as the wave function, or wave functions are called as atomic orbitals. These atomic orbitals tells us about the size, shape and orientation of the electron in the space. I hope this is clear. So please note down all these things so that I can go into further discussion, that is how to identify uniquely the atomic orbitals. Okay, so to identify the atomic orbitals we require 4 different quantum numbers, and those quantum numbers we will be discussing. First note this down. Now to uniquely identify the orbital we have to have 4 set of numbers which we call as quantum numbers. Okay, 4 set of quantum numbers we require, and those 4 quantum numbers are principal quantum number, azimuthal quantum number or orbital quantum number, third is magnetic quantum number, and lastly spin quantum number. Okay, principal quantum number, it is represented by n. Okay, azimuthal quantum number is represented by L, azimuthal quantum number, or it is called as orbital quantum number. ठीक है, third quantum number, magnetic quantum number, is represented by M. ठीक है, और spin quantum number is represented by MS. I hope you understand this. So to identify atomic orbitals uniquely we require or the help of 4 numbers which we call as quantum numbers. N is the principal quantum number, L is the azimuthal quantum number, ML is the magnetic quantum number, and spin quantum number which is represented by MS. Okay, यहाँ पे कभी कभी तो simply M भी लिखते हैं, but you can have it this way also. So what does principal quantum number tell you? It tells us about the size of the orbital, how big is the house of the electron. Okay, it tells us about the size of the orbital, and it takes up values like 1, 2, 3, it can go on. Okay, these n values, they are also called as shells. If n is 1, then it is called as K shell. If n is 2, L shell, n is 3, M shell, n is 4, N shell. अगर n 5 है तो G shell हो जाएगा, O shell हो जाएगा, sorry, O shell. I hope this is clear. So what does the principal quantum number tell you? It tells you about the size of the orbital. How big is the size of the, how big is the house of the electron? We can understand it that way. I hope this is clear. That is called as principal quantum number. ठीक है. Second is azimuthal quantum number, and it gives us the shape of the orbital. It gives us the shape of the house. That way you can understand. Okay, and that azimuthal quantum number, which is represented by L, it can take values from 0, 1, 2 up to n minus 1. It can take values from 0, 1, 2 etc. till n minus 1. Okay. Remember this, the value of n determines the value of L. मतलब L का वैल्यू किस पे डिपेंड होगा? वैल्यू ऑफ n पे डिपेंड होगा. ठीक है, तो we will just find out the possible values of L, and you will also find the number of L values corresponding to that. So, if your value for n is 1, then L has only one value, that is 0, isn't it? क्योंकि at the most it can have how much? n minus 1. तो 1 minus 1 0 हो जाएगा. So, it can take only one value. ठीक है? n 2 है, then L can take value 0 and 1. Okay? 2 minus 1 1, वहाँ तक ही ले सकता है वो. n is 3, then L can have 0, 1 and 2. It cannot go beyond that, because 3 minus 1 will be equal to 2. वहाँ पे end हो जाना चाहिए. ठीक है? n is equal to 4, मतलब L का वैल्यूज़ क्या क्या हो सकता है? 0 हो सकता है, 1 हो सकता है, 2 हो सकता है, 3 हो सकता है. It can go on. Okay? So, that is how you can see that possible values of L when n values are known to you. अभी कितना number of L values है? There is only one value, so we can write 1. How many L values do you find here? 0 and 1, that is 2 values you have. 0, 1, 2, that means there are 3 values of L. 0, 1, 2, 3, therefore there are 4 values of L. I hope this is clear. Okay. We have said that it gives us the shape of the orbital. So, how to identify the shape? So, I will just rub this out and we can go into that. We will see values of L, shape of orbital and short form notation. Okay. So, if the value of L is equal to 0, then the shape of the orbital is spherical. Okay. Simply ऐसा एक sphere होगा. Okay. It is a spherical shape, and short form notation for that is small letter s. I hope this is clear. Okay. Now, when L is 1, then the shape is dumbbell shape. You know how the dumbbell shape is? ऐसे 2 लोब के साथ. This is called as dumbbell shape. Okay? और इसको हम represent करते हैं with the letter P. Okay? When L is equal to 2, मतलब उसका शेप क्या है? It is double dumbbell. इसका शेप ऐसा हो जाएगा. डबल डम्बल मतलब एक ये ऐसा डम्बल और दूसरा ऐसा. 2 lobes here, 2 lobes here. और इसको हम represent करते हैं with letter D. Okay? When L is equal to 3, that is when L is having value 2, वो ऑर्बिटल का शेप क्या है? डबल डम्बल शेप है. और उसका नोटेशन हम किस तरह से देते हैं? स्मॉल लेटर d से. When L is equal to 3 ना, ये शेप बहुत कॉम्प्लिकेटेड है. वी कैनॉट ड्रॉ इट ऑन द बोर्ड. सो सिंपली राइट इट इज़ अ कॉम्प्लिकेटेड शेप. Okay, not possible to draw on the board. Okay, and we represent it by the letter F. I hope this is clear. So, this is how you can identify the shape of the orbital. If the orbital is having value L is equal to 0, then the shape of that orbital is spherical, has to be represented by S. When L is 1, then it has a dumbbell shape. When L is 2, it has a double dumbbell shape which is having notation D. Dumbbell के लिए P है notation. Okay. When L is 3, then it has a complicated shape. We are not able to draw on the board. We should understand those orbitals will be denoted by F orbital, F letter. Okay. So, please note this down so that I can go further. Now, you see here that if n represents the shell, then L will represent the subshell. Okay. When n takes the value 1, 2, 3, 4, L takes the value 0, 1, 2, 3 up to n minus 1. This is what we had seen previously. Now coming to the next quantum number, which is magnetic quantum number, represented by M. In your book it is represented by ML, so you can write it as ML. In certain books you will find it as simply M. So that is also okay. Okay. So this magnetic quantum number ML, it tells us about the orientation of the orbital in the space. It tells you about the orientation of the orbital in the space. When L is 0, we said that the shape of the orbital will be spherical in nature. मतलब वो इस तरह से होगा, ठीक है. तो उसका कितना ओरिएंटेशन होगा स्पेस में. आप सपोज वी पुट द एक्सिस लाइक दिस इज एक्स एक्सिस, वाई एक्सिस, जेड एक्सिस. किसी भी तरह से घुमाओ एक ही ओरिएंटेशन मिलेगा हमें, क्योंकि ये स्फेरिकल है. सो द नंबर ऑफ ओरिएंटेशन इन दिस केस विल बी इक्वल टू 1. ठीक है. When L is 1, we said the shape of the orbital will be dumbbell shaped. ठीक है. उसमें भी अगर हम लोग ये एक्सिस बना दें, x axis, y axis and z axis, then this is one way of orientation. ठीक है. अगर हमने उसको 90 डिग्री ऐसे घुमा दिया तो हमें कैसे मिलेगा? We will get it in this manner. ये तुम्हारा एक्स वाई जेड है. अब इधर ऐसे जो था उसको हमने ऐसे घुमा दिया तो हमें इस तरह से मिलेगा. ओके, दिस इज योर एक्स एक्सिस, वाई एक्सिस, जेड एक्सिस. ओके, और भी कोई तरीका हो सकता है. वन मोर इट कैन बी, इजंट इट? आई विल ड्रॉ इट हियर. इसको और वापस 90 डिग्री इस तरफ को घुमा दिया तो आई गेट माई ऑर्बिटल इन दिस शेप. दिस इज योर जेड एक्सिस, वाई एक्सिस, x axis. So I have 3 possible orientations here. Okay, so 3 possible orientations are possible with L is equal to, ये देखो 3 possible orientation है. हाँ, इधर हमको एक ही orientation मिला था, वहाँ पे हमें 3 possible orientations मिला. इसको हम अब L is equal to 1 मतलब ऑर्बिटल का नाम क्या है? p ऑर्बिटल है. ठीक है. तो ये p ऑर्बिटल है. हम देख रहे हैं कि ये ऑर्बिटल किधर ओरिएंटेड है? ओवर द y axis, so we can write it as py. इसको हम कह सकते हैं px और इसको कह सकते हैं pz. तो there are 3 possible orientations when L is equal to 1. So therefore 3 orientations. ठीक है. Now when L is equal to 2, the orientations, L is equal to 2 मतलब शेप क्या होता है? डबल डम्बल होता है. तो डबल डम्बल शेप you can have it in this manner. There are various ways in which it can be oriented. ये जो है between the x and y axis, if the lobes are there, then it is called as dxy orientation. Between z and y, z and x axis है, you can see, then that will be called as dxz orbital, and the orientation is between, on this orientation will be called as dzx. ठीक है. अब x और y और z के बीच में है तो इट विल बी कॉल्ड एज dyz. सो बिटवीन y एंड z द ऑर्बिटल्स आर ओरिएंटेड, सो इट इज कॉल्ड एज dyz. ठीक है. व्हेन द ऑर्बिटल्स आर ओवर द x एक्सिस एंड y एक्सिस, देन दैट विल बी कॉल्ड एज dx स्क्वायर माइनस y स्क्वायर. ओके. एंड इफ वन ऑफ द ऑर्बिटल विल बी ओरिएंटेड ओवर द z एक्सिस, ये तुम्हारा z एक्सिस है, ये x एक्सिस है और ये y एक्सिस है, देन दिस विल बी कॉल्ड एज dz स्क्वायर. ओके. इट इज ऑल्सो नोन एज डोनट शेप्ड. ओके. इट इज ऑल्सो नोन एज डोनट शेप. सो विच ऑर्बिटल इज हैविंग अ डोनट शेप? देन इट इज dz स्क्वायर. आई होप दिस इज क्लियर. सो प्लीज नोट दिस डाउन. एंड फॉर f ऑर्बिटल्स, that is when L is equal to 3, this was L is equal to 2. When L is equal to 3, we are not having any figure, we cannot put it on the board for the orbitals, but we can say that for L is equal to 3, which are f orbitals, which is known as f orbitals, it has how many orientation? There will be 7 orientations available. Okay, 7 orientation. ये भी नोट डाउन कर लेना. L is equal to 2, there are total 5 orientation and L is equals to 3, F orbitals उनका कितना orientation है? 7 orientations है. Okay, so these things also you should note it down. Okay. So we had seen that for a given value of L, we were discussing about the magnetic quantum number, okay, ml, and ml का value किस पे depend होता है? On the values of L. So the given value, for any given value of L, there are 2L plus 1 orientation. मतलब m can take values from minus L 0 up to L. ठीक है. So suppose L, this is 2L plus 1, this is the orientation, that is the values of m. Okay, how many orientations are possible, and that those orientations can be given by the values of m. मतलब L का वैल्यू अगर 0 है तो इधर अगर हम L 0 रखें तो कितना ओरिएंटेशन मिलता है हमें? ओनली 1 ओरिएंटेशन. सो m का वैल्यू शुड बी इक्वल टू 0. L is 0, then m will be 0. ठीक है. Then when L is 1, that is when L takes the value 1, then number of orientation कितना होगा? यहाँ पे L का वैल्यू 1 रख के देखो तो कितना ओरिएंटेशन मिला हमें? 3 ओरिएंटेशन. Therefore m can take values, इधर लिखा है ना, m can take values from minus L 0 to L. So minus 1 0 to 1, because L का वैल्यू क्या है? 1 है, तो it can take minus 1 0 1. minus 1 मतलब उसका ओरिएंटेशन कौन सा होगा? px, py एंड pz. तो यू कैन जस्ट सी दैट. ऐसा कोई रिलेशन नहीं है कि px हमेशा -1 रहेगा उसका वैल्यू. वो conventionally we will just put it that way. Okay, there is no relation that px should only take value -1. px can also take it as 0 or pz can also take it as 0. Okay, so don't worry about that. When L is 0, L is 2, then you put your L value 2. So 2 into 2 4, 4 plus 1 5. There are 5 orientations. What are those 5 orientations? What are the values of m which it can take? It can take values from minus L to plus L. So minus L मतलब -2, इधर L का वैल्यू हमारा 2 है तो -2, उसके बाद क्या आता है? -1, फिर 0, फिर 1, फिर 2, up to 2 you can take. You cannot take -3, neither you can take beyond that, that is 3. Followed? When L is equal to 3, L इधर 3 रखो तो 7 orientations मिलता है. Orientations हम दिखा नहीं पाते बोर्ड पे, but you understand there are 7 orientations in the space, and those 7 orientations are shown by m values -3, -2, -1, 0, 1, 2, 3. So there are 7 orientations. Okay, so that is how L values are giving you the m values. That is, m value is dependent on the L values. I hope you understand that. एक एग्जाम्पल ले लेते हैं for so that you can understand little more. What does it say? For n is equal to 3, find the number of orbitals. For n is equal to 3, find the number of orbitals. n 3 है. That means L can take your value as 0, 1, 2. Previously we had seen. n अगर कोई भी नंबर है तो L क्या ले सकता है वैल्यूज? इट कैन टेक 0 to n-1. दैट मीन्स इट कैन टेक वैल्यूज फ्रॉम 0, 1, 2. ये इतना ही ले सकता है. ठीक है. जब L 0 है तो मतलब वो कौन सा ऑर्बिटल होता है? इट इज़ s ऑर्बिटल. प्रीवियसली वी हैड सीन. ओके, सो व्हेन L इज 0 दैट मीन्स इट इज़ हैविंग s ऑर्बिटल. और कौन सा शेल का है? थर्ड शेल का है, इसीलिए हम उसको कैसे रिप्रेजेंट करेंगे? 3s. ठीक है. सो इट हैज़ ओनली 1 ओरिएंटेशन. s का ओरिएंटेशन हमेशा 1 ही रहेगा. ओके. व्हेन L इज इक्वल टू 1 दैट मीन्स विच इज़ योर ऑर्बिटल? इट इज़ द 3p ऑर्बिटल. दैट इज थर्ड शेल का p ऑर्बिटल्स के बारे में हम बात कर रहे हैं. और p ऑर्बिटल्स का ओरिएंटेशन कितना है? 3 है. दैट इज 3px, 3py एंड 3pz. सो देर आर 3 ओरिएंटेशंस पॉसिबल फॉर L इज इक्वल टू 1. फॉर L इज इक्वल टू 2 मतलब वो कौन सा ऑर्बिटल हो जाता है? d ऑर्बिटल्स हो जाता है. और d ऑर्बिटल कितने होते हैं? 5 होते हैं. dxy, dyz, dzx, dx² minus y² and dz². तो देर आर सो मेनी ऑर्बिटल्स possible for D. 5 ओरिएंटेशंस होता है, ठीक है. सो देर आर 5 ओरिएंटेशंस फॉर D ऑर्बिटल्स. सो टोटल में कितना हो गया ऑर्बिटल्स? 1 2 3 टाइप्स आर देयर. फर्स्ट S ऑर्बिटल एक ही होता है, P ऑर्बिटल 3 होता है और D ऑर्बिटल्स 5 होते हैं. तो टोटल कितना ऑर्बिटल्स हुआ? 9 ऑर्बिटल्स हो गए. ओके, व्हेन वी डू क्वेश्चंस बेस्ड ऑन इट यू विल अंडरस्टैंड इट. बट नाउ यू जस्ट अंडरस्टैंड दिस कि L 0 वैल्यू है मतलब वो ऑर्बिटल कौन सा होता है? S ऑर्बिटल होता है, ठीक है. व्हेन L 1 होता है मतलब उसका ऑर्बिटल कौन सा है? नेम कौन सा है? P. शॉर्ट फॉर्म नोटेशन हमने लिखा था ना बोर्ड पे, तो वो P ऑर्बिटल्स होते हैं. कितने P ऑर्बिटल्स हो सकते हैं? 3px 3py और 3pz इन दिस केस. मतलब जो जिस शेल में है वो. Then when L is equal to 2 there are 5 orientations, 5 orbitals possible जहाँ पे D orbitals होंगे. L is equal to 2 represents D orbitals और कितने orbitals होते हैं? 5 orbitals. L is equal to 3 मतलब there are 7 orientations which is F orbitals. L is equal to 3 मतलब F orbitals था और F orbitals कितने हुए हैं? There are 7 F orbitals possible. Okay, so these things it should be clear. In the beginning you may find it very difficult to imagine all these things. So go through the video twice or thrice and relate it with the chapter, because these are very abstract concepts which you have to visualize. Okay, so you have to go through it for many times, then only you will be able to follow it. Okay, so don't get worried if you don't understand it in the beginning, but as you go on reading once, twice, thrice your textbook, you will be able to understand it. Okay, so L values will give you the corresponding M values. You understand that when L is 0, M has value 0. When L is 1, then M can have 3 values, -1, 0, 1, because there are 3 orientations. When L is 2, then M can take values -2, -1, 0, 1, 2. There are 5 orientations. Okay. L is 3, that means there are 7 orientations. Okay, these are the F orbitals which we are talking about. There will be 7 F orbitals. ये बात हमेशा याद रखना, जब L 0 है तो वो किसको represent करता है? S orbital को represent करता है. Please understand this, this is very important. L is 1 मतलब वो कौन सा orbital को represent करता है? P orbital को. Okay, when L is 2, it represents the D orbital. कोई भी शेल में हो, it will always represent the D orbital. Okay, and when L is 3, that means it will represent the F orbital. Please understand this very clearly. L 0 है मतलब S orbital होता है, L 1 है मतलब P orbital होता है, L 2 है मतलब D orbital और L 3 है मतलब F orbital होता है. Okay, L 4 है तब क्या होगा? G ऑर्बिटल, लेकिन उसके बारे में हम अभी नहीं पढ़ने वाले. ओके, सो वी विल अंडरस्टैंड दिस. द फोर्थ टाइप ऑफ क्वांटम नंबर इज स्पिन क्वांटम नंबर. एवरी इलेक्ट्रॉन हैज़ अ इनबिल्ट प्रॉपर्टी ऑफ अंडरगोइंग अ स्पिन in clockwise direction or in anti-clockwise direction. Okay, and that is represented by spin quantum number ms. Spin quantum number दो ही होते हैं, that is either +12 और -12. +12 तब होता है जब उसका clockwise movement हो, when the electron is moving clockwise direction. When the electron is rotating in the anti-clockwise direction, then we show by an arrow downwards, and that is represented with the value -12. So these are the 4 quantum numbers which enable us to find out exactly the position of the electron, in which shell, in which subshell, what is its orientation and what is its spin. ये सारा चीज़ें हमें ये 4 क्वांटम नंबर से पता चल जाता है. मतलब अगर हमको एक इलेक्ट्रॉन को लोकेट करना है तो इट गिव्स यू, इट इज़ गिवन बाय दीज 4 नंबर्स. n हमें वो बताता है कि वो कौन से ऑर्बिट में है, l हमें वो बताएगा कि वो किस ऑर्बिटल में है या किस सबशेल में है. इज इट इन s ऑर्बिटल और इज इट इन p सबशेल, इज इट इन d सबशेल और इज इट इन f सबशेल, वो हमें कौन सा नंबर्स बताएगा? l का वैल्यूज़ बताएगा. m का वैल्यूज़ क्या बताता है कि वो किस तरह से स्पेस में ओरिएंटेड है. Is it oriented in the px direction, or is it oriented in the py direction, or is it oriented in the pz direction? So these orientations are given by the m values. ठीक है, और ms वैल्यू हमें क्या बताता है, दैट इज स्पिन मैग्नेटिक नंबर क्या बताता है हमें, दैट इज telling you whether the electron is having a clockwise rotation or is it having an anti-clockwise rotation. Okay, so ये जो है this is spin orientation number. I hope this is clear. So this will exactly give you where the electron is there in a particular point in the space. Followed? Yes or no? Okay, so go through the things again and again, read the chapter and try to relate with that. So this is the 4 quantum numbers which is used to describe uniquely an atomic orbital or to locate an electron in a particular space. Okay, please note down. Now we had seen that solution of the Schrodinger equation gave you psi which is equal to, which is signified, this wave function is signified by 3 quantum numbers, that is n, l and m. Okay, and psi square is what? Psi mod square, it is equal to the probability density of an electron at a given point. Okay, supposing if a position of an electron has to be found, then it is characterized by these 3 coordinates x, y and z. That is when we think that an electron is moving in a circular orbit, then we can think of x, y and z. ठीक है, लेकिन ये जो x, y, z कार्टेशियन coordinates है, that couldn't give a proper view of the position of the electron. So instead of Cartesian coordinates, spherical polar coordinates were used. Atom was considered as a sphere, so a spherical polar coordinate was considered, where this was the x axis, this is the x axis, y axis and z axis, just like a sphere. So there now we have radius r, this is showing what? This is showing the radius r. We have 2 more angles, that is phi, the angle between this r and x axis which is phi, and this is theta. ये तीनों चीज़ें चाहिए है to find the overall position of an electron. So overall position of an electron can be found out by these 3 values, that is radius, angle phi and angle theta. So we have written this. Okay, this r represents the overall position of the electron, this is the radius of the polar coordinate. Okay, and these are the 2 angles. ठीक है, so now psi, n, l and m requires these 3 informations, radius, the 2 angles theta and phi. Okay. Now another concept which comes into our notice is node. Okay. Now what is a node? Node is a region where wave function has 0 value. Node is a region where the wave function has the value 0. That is psi mod square जो होता है उसका वैल्यू 0 हो जाता है, वहाँ पे हमें इलेक्ट्रॉन नहीं मिलता. द कैनॉट फाइंड एन इलेक्ट्रॉन. ओके, कैनॉट फाइंड एन इलेक्ट्रॉन, वो रीजन जहाँ पे हमें इलेक्ट्रॉन नहीं मिलता है, दैट इज़ कॉल्ड एज द व्हाट वी कॉल एज नोड. ओके, और ये जो नोड है या तो एक पॉइंट हो सकता है या एक प्लेन हो सकता है, anything it can be. Okay, it can either be a plane or it can be a point where you do not find the electron, and that region is called as node. ठीक है, अब इधर हमने जो wave function लिखा, that is psi, n, l and m, the wave function which is signified by these 3 numbers and which requires these 3 informations, it can be divided into 2 parts. One is r, n, l with radius, which is called as the radial component. Okay, then we have y, l, m with theta phi, which wave function है या total wave function, इसको हम क्या बोलते हैं? Total wave function. Okay, this is called as total wave function. This is total wave function, can be divided into radial component and angular component. ठीक है, जब एंगुलर कंपोनेंट, रेडियल कंपोनेंट जब 0 होता है, देन दोज नोड्स आर कॉल्ड एज रेडियल नोड्स. Okay, when angular components are 0, then that regions are called as, or those nodes are called as angular nodes. ठीक है, अब angular nodes के बारे में हम डिस्कस करते हैं. Angular nodes, that is when y lm theta phi it has a value equal to 0, the radial component becomes equal to 0. When L is 0, then it is spherical in nature, that means there will be no angular nodes there. ठीक है, spherical है, suppose this is the nucleus, then you will find that there is probability of finding electron everywhere. There won't be any region which has the value equal to 0, that is angular node will be cannot be equal to 0 in case of L is equal to 0. When L is equal to 1, मतलब ये p orbital है, तो वहाँ पे there is possibility of a px plane. This is when you have the orbital in this manner. When you have orbital in this manner, then the plane will be existing in this manner. Okay, so each one will have, px plane will have one node, py plane will have another node, and pz plane will also have another. This is the plane where you don't find an electron. Okay, so for px, py, pz each will have one node each. So therefore number of nodes in each case will be equal to 1. इधर हमने क्या represent किया है? Number of nodes. Okay, this is number of nodes. For L is equal to 0, there is no nodes. When L is equal to 1, then there is one nodes in each case, that is px, py and pz. Okay, then when L is equal to 2, then each d orbital has two nodal planes. It's difficult to represent here, but there will be two planes. ऐसे एक plane होगा. Okay, just a little imagination you put. There will be a node in this way, and there will be another nodal plane in this manner. So there are two nodal planes. So in each case there will be two nodal plane. So therefore number of nodes will be equal to 2 in this case. So what do you find? जितना L का value है उतना ही number of nodes है. So therefore angular nodes is actually equal to the L, value of L. Okay, so angular nodes will be, you can write it as angular nodes, it is equal to L only. Okay, so 2 in each case. I hope this is clear. So please note down. Now coming to radial nodes. Radial nodes में क्या होता है? जब R and L, the radius component, this component will be equal to 0. That is when we have radial nodes. Okay. Now when radial nodes was plotted against radius for the various orbitals, 1s orbital, 2s orbital, 3s orbital, we got the following plots. तो क्या हमें मिला जब हमने रेडियल नोड को 1s ऑर्बिटल का रेडियल नोड with respect to versus r was plotted, we got a curve this way. Okay, रेडियल कंपोनेंट को हमने r के साथ प्लॉट किया तो हमें इस तरह का एक ग्राफ मिला. और नोड क्या होता है? दैट रीजन व्हेन द r and l r becomes equal to 0. अब ये वाले प्लॉट में तुमको दिख रहा है दिस इज द प्लेस वेयर r इज इक्वल r and l r शुड बी इक्वल टू 0. तो यहाँ पे ऐसा ये कर्व में कहीं पर भी ये 0 पे नहीं आ रहा है. सो देयर इज नो नोड फॉर 1s ऑर्बिटल. ओके, व्हेन इट वाज प्लॉटेड फॉर 2s ऑर्बिटल इस तरह का कर्व मिला. जैसे यहाँ से यहाँ तक आ गया, यहाँ 0 पे आ गया, मतलब यहाँ पे वेव फंक्शन बिकम्स इक्वल टू 0. दिस इज द रेडियल वेव फंक्शन है ना, रेडियल पार्ट ऑफ द वेव फंक्शन. दिस रेडियल वेव फंक्शन बिकेम इक्वल टू 0 एट दिस पॉइंट. देयरफॉर वी डोंट फाइंड इलेक्ट्रॉन्स एट दैट पॉइंट, और वो पॉइंट वी कॉल इट एज नोड है ना. तो कितना नोड है इधर? एक ही नोड है ना, बाकी कहीं पर भी वो 0 पे कोइंसाइड नहीं हो रहा है. r का वैल्यू 0, r and l r शुड बी इक्वल टू 0 मीन्स ये है ना तुम्हारा 0. So whenever this is having a intersection with x axis, that is the point where we say that the wave function will be equal to 0. और इधर कहीं पर भी एक ही जगह पे हो रहा है और कहीं नहीं हो रहा है. ठीक है. थर्ड वाले में that is 3s ऑर्बिटल में you can see that the curve इस तरह से आता है. पहले यहाँ 0 पे आ गया, फिर नीचे गया, that is नेगेटिवली गया, और फिर अगेन इट गोज अप. तो यहाँ पे दो जगह पे वो 0 हो जा रहा है. So these are called as the nodes, isn't it? And so therefore 3s is having 2 nodes. Clear? When we plotted for p orbitals, that is 2p orbital, we could see that there was no node. ठीक है, 3p के लिए plot किया तो again we got one node. Okay, so from this if you just put it down in a table manner, 1s जब plot किया था उसमें हमें कितना nodes मिला? 0 मिला. 2s 1 मिला, 3s 2 मिला, 2p 0 मिला, 3p 1 मिला. तो इससे हमें एक फॉर्मूला मिल जाता है कि नंबर ऑफ रेडियल नोड्स शुड बी इक्वल टू n माइनस l माइनस 1. होता है कि नहीं? देखो n इन दिस फर्स्ट केस, इधर हमारा n क्या है? 1 है ना, क्योंकि फर्स्ट ऑर्बिट है, उसमें s ऑर्बिटल के बारे में हम बात कर रहे हैं. सो n इज 1, l इज s ऑर्बिटल है, मतलब उसका l का वैल्यू 0 होता है. सो 1 माइनस 0 माइनस 1 इट इज़ इक्वल टू 0, है ना. 1 माइनस 0 माइनस 1, तो ये बिल हो जाएगा ना 0. सो यू गॉट दैट करेक्ट. 2s मतलब सेकेंड ऑर्बिट का s ऑर्बिटल. सो s ऑर्बिटल जब भी आता है l का वैल्यू क्या हो जाएगा? 0 हो जाएगा. सो 2 माइनस 0 माइनस 1 मतलब 2 माइनस 1 हो गया. ठीक है. 3s ऑर्बिटल मतलब थर्ड ऑर्बिट का s ऑर्बिटल, मतलब l का वैल्यू उधर 0 हो जाएगा. सो इट इज़ 3 माइनस 0 माइनस 1 मतलब 2 हो जाएगा. 3 माइनस 1 विल बी इक्वल टू 2. ओके. 2p मतलब सेकेंड ऑर्बिट का p ऑर्बिटल. ओके. सो सेकेंड ऑर्बिट n का वैल्यू 2 होगा, l का वैल्यू जब p है मतलब l का वैल्यू शुड बी 1. ओके. और ये माइनस 1. सो 2 माइनस 1 माइनस 1 दैट विल बी 2 माइनस 2 इक्वल टू 0. तो हमें 0 नोड्स मिला. ओके. 3p that is third orbit minus l value 1 है and minus 1, that is 3 minus 1 minus 1 that is 3 minus 2 which will be equal to 1. उसी तरह से हम कोई भी ऑर्बिटल्स के लिए फाइंड कर सकते हैं. 3d होगा मतलब d का वैल्यू, d है मतलब l का वैल्यू शुड बी इक्वल टू 2. सो 3 माइनस 2 माइनस 1 दैट इज 3 माइनस 3 इक्वल टू 0. 4d इक्वल टू 4 होगा n का वैल्यू, l का वैल्यू, d है मतलब l का वैल्यू 2 होना चाहिए, माइनस 1. सो 4 माइनस 3 इक्वल टू 1. तो हम फाइंड कर सकते हैं रेडियल नोड्स. तो उसका फॉर्मूला हो जाता है ये. सो रेडियल नोड्स हैज़ द फॉर्मूला n माइनस l माइनस 1 एंड एंगुलर नोड्स विल बी l. ओके. प्रीवियसली हमने देखा था एंगुलर नोड्स इज एक्चुअली इक्वल टू द वैल्यू ऑफ l ओनली. इफ देर आर l का वैल्यू 2 है मतलब उसका एंगुलर नोड्स 2 है. ठीक है. So total nodes in a wave function will be equal to n minus l minus 1 plus l, that is n, l cancel हो जाएगा तो n minus 1. So total nodes you get it as n minus 1. Okay. So these are the various concepts which we learned today. Very important concepts are there. Please go through it again and again, read the chapter also and watch the videos twice or thrice. Then only you will be able to get the things. So please do that and in the next session we will take the next topic. Okay, thank you.